All right, what we're learning today is extremely important. What we're doing today, we're going to do every single day from here until the end of the semester, so make sure we can do it. So we're finding the following derivatives. What is the derivative of x squared? Slade told me that was 2x. Letter B, it says g of x is x squared plus 4. Caden, what's our derivative there going to be? It is 2x. And letter C, I got x squared minus 8. A and B, what's my derivative going to be there? 2x. Wonderful. All of them, when I take the derivative, get me 2x. So, easy. What if I gave you this one? I don't know what the original equation is, but I'm telling you what the derivative is. The derivative is 2x. What was the original equation that gave me a derivative of 2x? X squared. I'm hearing a lot of x squared. Does everybody agree with this on that? Great. It is definitely x squared. Is that it? I could have any other number. Because if I take the derivative of a constant, it would go away and we wouldn't know it. It could be nothing. It could be plus 4. It could be minus 8. We don't know. Okay? So it's x squared plus something. There could be something added on to the end of that thing. We don't know what is added on. It could be nothing. It could be 0. But it's plus something. We are going to use the letter C. The letter C is a constant. It just represents some constant. And again, it could be 0. But every time we talk about finding an antiderivative, we have to include a plus C. Because that plus C could have been there. There could have been a number, but when we took the derivative, it would go away. So we don't know necessarily if it was there or not. That's what we're working with today. All right? And so 2x became x squared. So think about that process. 2x became x squared. Let's try 2 more here as I pass out notes. What would the antiderivative of 3x squared and what would the antiderivative of sine x be? Talk with your neighbor. Think your way through it. See what you got. All right, we got 3x squared is the derivative. I'm trying to decide what came before it. What, when I take the derivative of it, is going to get me 3x squared. Anybody got an idea there? X cubed and then good plus C. There could have been a constant there. Maybe there was a plus 5, and when we took the derivative, it went away. But we got x cubed. Think about it. To take the derivative, you multiply by the exponent, and then you subtract 1 from the exponent. Oh, yeah, that makes sense. Today, we're going the opposite direction. So here's what we're going to think about today. To go from here to there, I'm going to add 1 to my exponent. So 2 is going to become 3. We added 1 to our exponent. And then we are going to divide by our new exponent. So since my new exponent is 3, I'm going to divide by 3. Oh, yeah, that gets me 1. That is how we do antiderivatives. We add 1 to our exponent and then divide by our new exponent. Okay, that's what we're going to do here in a second. And then what about g of x? I take the derivative of something and it gets me sine. What when I take the derivative of it gets me sine? It is negative cosine. Think of Snapchat, negative Snapchat. We are up here at sine is what we've got. Normally, we would go this direction when we take a derivative, but we're not taking a derivative. We're going the opposite direction. We're going backwards. So instead of sine, we get negative cosine would be there instead. This it? Plus C, because there could have been a constant there that when I take the derivative of a number like 2, it would go away. Questions? Let's do it. Break out your notes. Let's look at them. Up in this top corner, there is some great stuff up here. Okay? That is just understanding how to rewrite some things. We're going to talk about all of those within our lesson today. But if you're lost on something later on, checking back up there and understanding what's going on would be helpful to you. Okay? Again, today we are finding an antiderivative. We are doing the opposite of a derivative. We're starting with the derivative and getting back to the original. To do that, we are going to add 1 to the exponents and then divide by the new exponent. Those are our 2 steps. Add 1 to our exponent and then divide by that new exponent. Those are our concepts that we're going to deal with here. And then always, we are going to include plus C because there could have been a constant. And when I took the derivative, it went away. Let's do it. Find the following antiderivatives. So they gave me the derivative We're doing the antiderivative, so we're going to find the thing that comes before it. We represent that normally with the capital letter of whatever we had. So G prime would become capital G and so on. 6x cubed minus 8x to the negative fifth plus 7. We are going to find the antiderivative of that. Okay, so my first thing here, I look here, these are all just polynomials, so these should be pretty easy. We start off with x. We're going to add 1 to our exponent. So what's my new exponent going to be? 4. And then I'm going to divide by my new exponent. So my new exponent of 4, I'm going to divide the original constant by that. So I'm taking 6, and I'm going to divide it by 4. What's my new leading coefficient going to be? 3/2. We got my next one, 8x to the negative fifth. It was x to the negative fifth. I'm going to add 1 to my exponent. So if I add 1 to my exponent, Jesse, what's my new exponent going to be? It is negative 4 now, because we're going negative 5 plus 1. Be careful with your negatives. Sometimes kids make mistakes. Show me with your fingers, what's your new leading coefficient going to be? My new leading coefficient is going to be 2, positive 2, because I'm going to divide by my new exponent. Negative 8 divided by negative 4. Oh, yeah, it's positive 2. And then 7. I'm adding 1 to my exponent. So my new exponent is going to be x to the first. X to the first, because it wasn't there. I'm adding 1, so now it's x to the first. I'm going to divide by my new exponent, so I'm dividing by 1. And so my leading coefficient is just 7, 7x. Think about it. It should make sense. Derivative 7x, oh yeah, it's 7. Okay, we're doing the opposite of taking a derivative. This isn't it. This is not the right answer. Plus c. Every time we take an antiderivative, you got to include plus c because there could have been a constant that we didn't know about. I'm going to bring it up so many times, you're going to be incredibly annoyed by me. But if you do not have plus c at the end, you do not have the right answer. Questions with number 1. Number 2. Just looking at number 2, it's ugly. Okay? Just like we did first semester, if something looks ugly, we can do math to make it simpler, to make it a little more organized. And that's what we're going to do here. Okay? We're going to rewrite this thing. Okay? So I'm not doing any calculus here. This is all algebra 1, algebra 2 stuff. I'm going to rewrite it. For example, square root of x. No, I'm not messing with that. What could I make it instead of square root of x? It would be the same thing as what? X to the 1/2. Okay? And right now I've got 2 x's in this problem and they're being multiplied. So you're thinking like product rule and stuff. We don't want to mess with that. So instead, we can just distribute because they're being multiplied. So 3x to the 1/2 times x to the 1/2. 3x to the 1/2 times x to the 1/2. What do we do with exponents when we're multiplying two things together? Add them. So what's my new exponent going to be? Just x. It is 3x to the first power because 1/2 plus 1/2 gets me 1. Plus 3x to the 1/2. All this is together. 3x to the 1/2 times 2. 3x to the 1/2 times 2 would be 6x to the 1/2. That's just rewriting. I did nothing fancy there. Again, all I did was distribute that in. So don't let that be weird. But I made it a lot easier. Now it's a polynomial. We'd much rather deal with it's not a polynomial, but it's written in that fashion. It's going to be a lot easier to understand. Everybody good? We did no calculus. Now we're going to do the calculus. So we have f prime of x. We're going to find capital F of x. Think with your neighbor for a second. Add 1 to your exponent, divide by your new exponent. See what you get. So let's do it. 3x plus 6x to the 1/2 power. Austin, what's my new exponent going to be on 3x? 2, because I'm adding 1 to my exponent. Now it's x squared. What do I got to do with that new exponent? Divide. So what's my new leading coefficient going to be? 3/2 x squared. Good. 3/2 x squared. Then I'm working on my next one. 6x to the 1/2 power. I am adding 1 to my exponent. So Dylan, what's my new exponent going to be? 3/2. Okay, think about what he's doing. He's taking 1/2 plus 1. So it's like plus 2 over 2. So 1/2 plus 2/2 is 3/2. Great. Now we need to get our new exponent. So we add 1 to our exponent and then divide by our new exponent. So what are you going to do if you're dividing by a fraction? multiply by the reciprocal. So what are you going to multiply by here? 2/3. We're multiplying by the reciprocal. We're dividing by 3/2, but no one wants to do that. Instead, we multiply by the reciprocal. Show me with your fingers. What's your new leading coefficient going to be? It's 4, because 12 divided by 3, it's 4. Is that my answer? Plus C, because there could have been a constant that went away when I took the derivative. Boom, that is my answer there. Questions through 2. This is all we're doing all second semester. So if at first glance it looks a little weird to you, great. We're going to do it a bunch. Let's do number 3. Let's just kind of work through it together. Hey, look, the directions changed. Up here we found an antiderivative. Right here we found an indefinite integral. This is called an indefinite integral because there's not any bounds on that thing. Okay, in every problem we've done so far, we found the area under the curve. There's been a number like 0 and 2. This is called indefinite because we don't have those numbers. An indefinite integral just means find the antiderivative. It's exactly the same directions. Okay, they look different, but it means the same. You got the integral with dx. There's no numbers. We're just finding the antiderivative. So let's do that. 9x squared. So Luke, what's my new exponent going to be? 3. He adds 1 to his exponent. It's 3. What's your new leading coefficient going to be? Also 3, because he's dividing by his new exponent. It gave me 3. My next one here, Maddie, what's your new exponent going to be? It's 2, because we add 1 to our exponent, it's x squared. And then you divide by your new exponent. So what are you going to have for your leading coefficient? -2. Good. 4 divided by 2. Yeah, it's -2. Then we get to the weird one, 1 over x. I hate 1 over x. Instead of 1 over x, let's rewrite that using negative exponents. 1 over x is the same thing as x to the -1. Everybody agree with me on that? 1 over x is like x to the -1. So we are going to add 1 to our exponent. So our new exponent's going to be 0. And then I'm going to divide by the 0. That's bad. In math, you know you can't divide by 0. That's terrible. Okay, that's not something that happens. So that should set an alarm off in your brain. If I add 1 to my exponent, it gave me 0, and then I'm dividing by 0. Bad stuff. Okay, so instead, think about this. What function, when you take the derivative of it, gets you 1 over x? Think about what we did first semester. What, when you take the derivative of it, gets you 1 over x? Natural log. First semester, we did this one all the time. What's the derivative of natural log? 1 over. Okay, 1 over x. Same thing is true here. So right here, it's going to be plus. Oh, I see 1 over x. It's natural log of x. Notice the absolute value signs. Okay, those matter. When you take the antiderivative of 1 over x, it's natural log of x, but it's in absolute values because you cannot take the log of a negative value. Okay, that's just a thing that builds in. When you create natural log by doing an antiderivative, you have to include absolute values. Plus 5, I'm taking the antiderivative of 5, so I'm adding 1 to my exponent. So what's my new exponent going to be? 5x. Done. Plus c. Do not forget the plus c. You need it. That is my answer. Questions on 3? We doing all right? Number 4. At first glance, number 4 is ugly. We don't like fractions. There's x's all over the place. That's rough. Okay? But again, by rewriting stuff, it's going to make the problem a lot easier. So that's what we're going to do here. Okay? This is something we did a little bit first semester, not a ton. But we're going to do something called splitting the fraction. You can do this because there's just one thing in the denominator. Since there's just an x to the 7th in the denominator, you can split it. Here's what I mean by that. You're going to rewrite it so that it's each part over x to the 7th. So for example, I can have x to the 4th over x to the 7th minus 3x to the 5th over x to the 7th. And then x to the 8th over x to the 7th. I just split the fraction. That's still a true statement. I just took all the parts and split them up. Okay? Just the same as like if I had like 1 plus 3 over 4, that would be the same thing as 1/4 plus 3/4. Oh, yeah, those are the same. That's why I can split that fraction if I just have a single term on bottom. I still don't like this. It's still really ugly. There's a whole bunch of x's involved. So let's do one more time and let's try to rewrite it. Okay, so x to the 4th over x to the 7th. How could I rewrite x to the 4th over x to the 7th? X to the 3rd and the 3 is negative. Because that 7 is bigger on bottom, we can subtract the exponents. It's x to the negative 3rd. Minus 3. The 3 is a constant. Constants hang out all the time, so it's a 3. X to the 5th over x to the 7th. X to the negative 2. Plus x to the 8th over x to the 7th. That would be x. Don't forget that dx. You've seen that dx already. It's important every single time. It ends the integral. Otherwise, it goes on forever. We need an ending point to say, hey, this is what I'm taking the integral of. Yes, ma'am.
Would it be wrong if we put everything in parentheses and let the dx outside of it?
No, absolutely not. If you put this in parentheses, put the parentheses before the integral. Yeah, yes, absolutely. That's good. Good. We didn't do any calculus yet. Now do the calculus. Find the antiderivative. Go. Finding the antiderivative, so x to the negative 3, we're adding 1 to our exponent. So Jacob, what's my new exponent going to be? Negative what? Yep, good. Negative 2. And then I got to divide by my new exponent. So what's my new leading coefficient going to be? Perfect. Negative 1/2. He's dividing by negative 2. So it's negative 1/2. Next one. Cannon, what's my new exponent going to be? I'm adding 1 to this. So I get negative 1. And then I divide by my new exponent. So my leading coefficient is going to be positive 3. Great. And then I've got x. Taylor, what's my new exponent going to be? X squared. And then you got to divide by your new exponent. So what's my new leading coefficient going to be? 1/2. We good? Plus c. I'm going to ask we good every time before we move on to the next problem because I want it stuck in your brain. Plus c. Stuck in your brain every single time. Plus c when we find an antiderivative. Questions through number 4. Yes, sir. No, because when we take the integral, that dx is going away. We're taking the derivative with respect to x, or the antiderivative with respect to x in that case. That answer is, yeah, just that. Yep. Let's go to number 5. Okay, there's some craziness here. Again, rewrite. You see radicals. You don't want to do anything with radicals. We want to rewrite that thing. So again, I'm not doing any calculus yet. I'm just rewriting. 3 square root of x. That is the same thing as 3x to the 1/2 power. And then 1 over the square root of x. Negative 1/2 because it's on bottom and it's square rooted. So on bottom it makes it negative, square rooted it's 1/2. Secant squared x, cool, leave it. Find the antiderivative. Find the antiderivative. Talk with your neighbor. Let's find the antiderivative. 3x to 1/2. We're finding the antiderivative here. So capital F of x. We're going to go ahead and label that. The other ones we were just doing it, so we didn't necessarily have to label. But this one we should. Max, what's my new exponent going to be if it was x to the 1/2? 3 over 2 because he's adding 1 to his exponent. And then you got to divide by your new exponent. So what are you doing if you're really dividing by 3/2? Good. Multiply by 2, divide by 3. So what's your new leading coefficient going to be? 2. Good. Those 3's would cancel and get you 2. Good. Next one. X to negative 1/2. We're adding 1 to our exponent. So if we're adding 1 to the exponent, Aiden H, what's my new exponent going to be? 1/2 because he's adding 1 to negative 1/2. So it becomes a positive 1/2. Then you are dividing by your new exponent. So what's your leading coefficient going to be? 2 because he's multiplying by the reciprocal. So it's like multiplying by 2 over 1. 2x to 1/2. And then we get secant squared. We don't have a good rule for that. You should just recognize it. What, when you take the derivative of it, gets you secant squared? That is tangent. That's something we've done before. It's been a minute, but you got to remember, what's the derivative of tangent? It's secant squared. So what's the antiderivative of secant squared? Tangent. Everything? Plus c. There's my answer. Let's keep going. You're doing well. We got 3 left. Okay. Number 6. f prime of x is equal to that. We are trying to find capital F of x. Talk with your neighbor, brainstorm, think about it, go. We're finding the antiderivative of e to the x. What, when you take the derivative of it, would get you e to the x? Yeah, we're going to throw a plus c at the end, but it's e to the x. E to the x is the antiderivative of e to the x, because the derivative of e to the x is e to the x. Easy. Minus 5 sine x. Here's the best news. That negative 5 is a constant. So just, it's going to stay there. Then all I have to think about is what is the antiderivative of sine. And if you're not sure, Snapchat, negative Snapchat. Right now we're at sine. We're finding the antiderivative of sine. So what would that be? Negative cosine. So cosine, and then it's negative. So it's positive. Or you could have said, hey, I've got negative sine, and what's the antiderivative of negative? Oh, it's positive cosine. Either way is fine. It would get you positive no matter what. And then my last one here. I've got a 2. Great. Antiderivative of cosine. What comes before cosine? Sine. So it's 2 sine x plus c. Don't forget it. Plus c. Done. It is for that whole thing. Because if we just did a plus c, good question, a plus c on EDX, and then I would need a plus c here, I would need a plus c here, and a plus c there. So you're adding a bunch of constants. And so what we're doing is saying, yeah, there's a bunch of constants. Let's add them all together and just make one big old constant in the end. There could be a plus c on each one, but we're just going to say, hey, it's and some constants at the end maybe. Yes, ma'am.
So why don't, I think I'm just not intelligent about this, but when it says, like, why don't we have to say cosine x squared? Yeah. Or sine x squared?
Because that's not what the antiderivative of cosine is.
Because
so
x is like,
it's a different function. It's not a polynomial.
okay.
All right, so you're not adding one to our exponent here.
Yeah.
You're just thinking, what when I take the derivative of it gets me cosine? Well, the derivative is sine 2 sine x. It'd be 2 cosine x. Oh yeah, that's what I want. All right, so it's a different world. We deal with add one to our exponent and divide by an exponent is when we have exponents.
Okay.
We have to adjust if it's a little bit different. Okay. If it's a different function. Here we go. Stay with me. Here we got 2 more. I'm moving a little slow. I want to make sure we get them all in. Let's look at this one together here. So when in doubt, rewrite it. 1 over x, x to the negative 1. X to the negative 2. And then the square root of x cubed. How could I rewrite the square root of x cubed? X to the 3 halves. That is the integral. I haven't done it yet. Now find the antiderivative. Do it quickly. Go. I'm just speeding this up here. 1 over x. What is the if I add 1 to my exponent, what's my new exponent going to be? 0. That's an alarm in my brain. So what is the antiderivative of x to the negative 1 or 1 over x? Natural log, absolute value of x. Don't forget those absolute value signs. Negative 1/2 x to the negative 2. Roslyn, what's my new exponent going to be? Negative 1. She added 1 to her exponent, so it became negative 1. And then you're dividing by your new exponent. So what's your new leading coefficient going to be? Plus 1/2. Excellent. My last one, x to the 3 halves. So I'm adding 1 to my exponent. Slade, what's my new exponent going to be? 5 halves, because he's taking 3 halves plus 2 over 2. 5 halves. Then what's your new leading coefficient going to be? 2/5, because he's dividing by his new exponent. We get that 2/5 in front, plus c at the end. There's that one. Questions there? One more. Here we go. Try number 8 without me. Use your brain. Careful on this last part. That one's going to throw you off a little bit. Last period, nobody got it right. See if you can be the one. See what you got. We are finding antiderivatives. 3x to the 4th. So Ella, what's your new exponent going to be? 5. And then you got to divide by your new exponent. So what's your leading coefficient going to be? 3/5. Excellent. Harley, I got to add 1 to my exponent for x to the 2/3. So what's your new exponent going to be? Good. 5/3. And then you're dividing by your new exponent. Good, because you're dividing by the fraction, so you're multiplied by the reciprocal. The 5s would cancel. It gets her -3. Great. And then we've got x to the -3. So I'm doing x to the -3. Maisie, what's your new exponent going to be? -2. And then you've got to divide by your new exponent. So what's your new leading coefficient going to be? Wonderful. -1/2 because you're dividing by -2. And then we get to this last guy, -e to the 2x. It's going to be negative because the negative is going to stay there. And we're not ready for this yet. I'm going to teach it to you again in the future, and I'll spend a whole day on it, but I'm going to throw it at you, see what you got. Anybody got an idea what that's going to be? What do you got, Dylan?
Minus e to the 2x times x plus c.
Not times x.
Okay.
So I agree. You need this e to the 2x. I need a coefficient in front. Think about it. This is what I'm asking you, right? I'm asking you, I don't know what f of x is, but I'm saying the derivative is e to the 2x. It's going to involve e to the 2x. What, when you take the derivative of it, would get you just e to the 2x? It is a 1/2 in front. Because the derivative of e is what you see times the derivative of the exponent. So if I had this 1/2 here, if I multiply by the derivative of the exponent, it would get me a 2. Those two things would cancel. We're not ready for that yet. I'm going to teach it to you again later on, but that is correct. And then plus c. Questions with that? Tomorrow, we're going to finish the bottom of those notes.